Hello, this is Peter Newman with part 7, and what we're seeing is the force convergence plot that looks very similar to what we saw in an earlier video. And we have a step 1, a step 2, and then during step 3 the solver decided it wasn't making good progress and did a bisection, which means to cut the size of the load step in half and start over, and it wasn't making good progress, and I actually stopped the solver from running at this point so we could look at what happened. And what we do is we look at the Newton-Raphson residuals, and by clicking on them we see that there's a maximum force imbalance here. And if we look at the maximum in the details window, it says it's on the bucket, and actually we asked for 4 of those, and all 4 of those last 4 points on this plot, these last 4 points all show the same place. The solver cannot remove the imbalance in this area. And if you recall, in a earlier video I said something about the fact that when, let me hide all the soil and fit the view, when I said about making the remote force, I could have picked these side skirts to include in the remote force as rigidly held. I probably should have done that, because I believe that's the reason why there's a force imbalance that cannot be resolved. The issue is this was all after a much finer mesh. I didn't put a super fine mesh on the buckets, and if I add the skirts to be part of the rigid force that's being applied to the buckets, I won't need a finer mesh, because they'll be braced up with the let me show you. Here is the bracing that's going on from the rigid point and to the tops, and if I add the skirts, there'll be all these rigid links around the skirts to this point of load application, and that will help the solver not have any flexibility there that is causing force imbalance. But let's hide the buckets for now. Let's show all the soil and instead hide the buckets. In earlier videos we saw a very coarse mesh, and that took very little time to solve. So we solved this model on a machine that has 14 cores. It's got 16 cores, and 14 of them were assigned to solving. And if we go to solution information and look instead at the solver output, at the bottom we see how long it took to run, and that is 16 hours of computing. So we want to make changes wisely to avoid a 16-hour wait time, and that's what it'll take to find out if adding the skirts of the buckets lets the solver get past this next point, which is why you want to spend a good amount of time ironing the bugs out with a very coarse mesh, and only when the model's running well to put a lot more elements in. But that said, let's take a little look at the results, and here is the deformation in millimeters in the x direction. So this is all of the bodies. Here are the buckets, and actually let me turn on all bodies. So back to geometry for a second. I can't show the buckets if they're hidden, so show all bodies. There we go. And now in the results, here is the deformation for all bodies, so 13 of them. I've got one which is just the outside soil and how that deformed, and then how the buckets deformed, and you can see that this side is having a positive displacement in X, and the back side is lagging behind and being left behind as the tops are pushed this direction. The soil inside the buckets is responding in this way, and then again, that was all of them. So the corrective action in this case is going to be to add the skirts of the buckets to the remote force rigid links, and we'll hit solve and hope that it makes more progress. So I hope that was useful. Good luck and goodbye.